this is Mr. Underkoffler, and today we're going to be looking at reflections on the coordinate plane. This is our second lesson on transformations. The first one was on translations. All right, follow along with me. A transformation, as I had taught you before, is an operation that maps an original geometric figure onto a new figure called the image. For certain types of transformations, the original figure and its image are congruent figures. Congruent figures have the same shape and same size. One of the common transformations on the coordinate plane is a reflection. Now, full disclosure, most of those sentences were the exact same sentences that you found on the guided notes for translations, except for that last one. Let's go ahead and talk about what reflections are. Reflections are often called a flip. You might recall translations were called a slide, but reflections are called a flip. And you'll notice here that the capital B, which is in blue, if I reflect it over the y-axis, now it has been flipped over it. So that's one of the words we'll use for reflections, is a flip. The figures are mirror images of each other, and you can see that here on the drawing with the blue capital B and the green one. The reflected image and the original image are congruent. They are the exact same size. However, this next part is key. The orientation is going to be different for the image than what it was from the original figure. You can see here with the blue capital B, the curves here are on the right. But once we flip it over the y-axis, reflect it over the y-axis, now the curves are on the left and the straight side is on the right. So that's what I mean here by a flip, and how the orientation is different from what it used to be on the original figure. A reflection is when you flip a figure over a line. That line is going to be called the line of reflection. Now, the example we have here was it being reflected over the y-axis. We could also reflect something over the x-axis. If you continue looking here in your guided notes, you're going to see two different examples here. Follow along with me as I read this out loud. It says, when reflecting a figure, every point of the original figure has a corresponding point on the other side of the line of reflection. Corresponding points are the same distance from the line of reflection. So if I reflect it over the x-axis, which you'll recall the x-axis is the one that goes left and right, you can see here that the point 2, 1 is one space away from the x-axis, and when I reflect it over the x-axis, that point is still 1 point away, or one space away from the x-axis, and that's why it becomes 2, -1. Likewise over here, 5, 1. When I flip it over the x-axis, it's going to become 5, -1. It's still one space away from the x-axis. Now, something I need you to observe here. The x-coordinates do not change when you flip a shape over the x-axis. And so I wrote this for you here in this little information box. The x-coordinates are the same. However, the y-coordinates do change. Now, I hope you can see the relationship here. It used to be 2, 1, now it's 2, -1. Over here was 5, 1, now it's 5, -1. Way up here it was 3, 4, but when I flip it, it's now 3, -4. So the y-coordinates will become the opposites of each other. That's only when you reflect a shape over the x-axis. In contrast to that, let's look at what happens when I reflect something over the y-axis. Now, you recall the y-axis is the one that goes up and down. So what happened on this situation? The point 2, 1. Once I reflect it over the y-axis, now it's -2, 1. So it's still 2 spaces away from the y-axis like it used to be, but now it's -2, 1 instead of +2, 1. What about the point 5, 1? When I flip it over the y-axis, it's now -5, 1. So do you see what's happening here? The y-coordinates are the same, but now the x-coordinates are opposites of what they used to be. It used to be +2 for the x, now it's -2. It used to be +5 for the x, now it's -5 once I reflect it over the y-axis. Same thing over here. It used to be +3, now it's -3. So this is what happens when you reflect things over the y-axis. Now, we can make some other conclusions here. Instead of saying the word opposites, like you heard me say here, in the information boxes, we can also treat it as the idea of multiplying the coordinate by -1. So, to reflect a point over the x-axis, you can follow along as I read this out loud, you're going to keep the x-coordinate the same, but you're going to end up multiplying the y-coordinate by -1. However, when you reflect a point over the y-axis, you'll keep the y-coordinate the same and then multiply the x-coordinate by -1. And you guys can see that here on these visual examples that I've given for you on your guided notes. All right, let's go ahead and turn the page and look at problem number 1. Now, this one is already 100% typed up for you, but I have certain things covered up so that way you can follow along with me here on the video to see how you would do this problem if you were going to do it on your own, even though it's already fully typed up for you on your guided notes. It says the vertices of figure D, E, F, G are, and you can go ahead and see what they are. I'm not going to read them out loud to you. The directions say graph the figure and its image after a reflection over the y-axis. So please take note here. There's actually two parts to the directions. The first part is to graph the original figure. The second part is then to graph its image. You might recall the vocabulary word image means the new figure after a transformation has occurred. In this case, we are talking about the transformation being a reflection over the y-axis. Now, very important that you are paying attention to which axis we are reflecting it over. We are reflecting it over the y-axis. If you have a highlighter at home, you might want to highlight the axis that you are going to have to reflect it over. So, what do we need to do? Well, when we reflect a point over the y-axis, recall what we just learned from the previous examples. I'll highlight it for you here. When you reflect something over the y-axis, the y-coordinates are going to stay the same, but the x-coordinates are going to become opposites of each other. So that's what I'm starting to give you here in this little think statement. When you reflect something over the y-axis, the y-coordinates will remain the same. However, the x-coordinates are going to become their opposites. All right, so you're basically just going to multiply them by -1. So first things first, let's graph the original figure. 4, -2, 5, -5, 2, -4, and 1, -1. If you would graph that on your own, this is what you would end up getting. You can see this is a parallelogram. We want to reflect that over the y-axis. So let's take, for example, the ordered pair of point D, which used to be 4, -2. When I reflect that over the y-axis, putting me somewhere over here, you can see I tried to highlight it for you here, that's now going to keep the y-coordinate the same. But the x-coordinate is now going to, instead of being a positive, it's now going to the left of the y-axis, so now that would make the x-coordinate become a negative. And that is why you would get -4, -2. And you can see that here with D going to D prime. Same idea with the E. If I take E and I reflect it over the y-axis, the y-coordinate's still going to be the same. It's still going to be 5 spaces below the x-axis, but when I reflect it over the y-axis, the +5 for the x value will now become a -5. And that's going to continue staying in that same pattern for all these ordered pairs. And there you go. Now I'm able to graph the new image from reflecting it over the y-axis. Now, some kids like to go ahead and draw it first. Other students would actually want to do what I did over here on the left, where they realize what's going to happen with the x-coordinates becoming their opposites, and so they might actually write the ordered pairs first, then graph it. I honestly don't care which way you do it. It's a matter of personal preference. If you want to graph it first, then write the ordered pairs, or maybe write the ordered pairs first, then graph it. Either way is going to work. All right, problem number 2. If you think you can do this on your own, go ahead and do this problem on your own. If you're not feeling comfortable yet on doing this on your own, then follow along with me as I lead you through it. All right, here we go. It says the vertices of triangle ABC are, and then they tell you what they are. It says graph the triangle and its image after reflection over the x-axis. All right, first things first, let's graph the original triangle. A would be 4, -2, so I go right 4, then down 2. B is 0, 2, so I don't go right or left at all, but I have to go up 2. And then C is 5, 2, so I go right 5, and then I go up 2 spaces. And it says we're going to graph that triangle. So go ahead and connect the dots, and there's your triangle. Now, what are we reflecting it over? Please double check that you are following directions. We are reflecting it over the x-axis. Here's the x-axis. That's what I need to reflect it over. So, the A used to be down here. When I reflect it, it's going to put A prime up here. Still the same X value, but it's getting reflected up, flipped up above that X-axis. So that's where A prime would be located. Now, if you want to go with writing out the ordered pairs, maybe that's an easier way for you. A used to be 4, -2, but when you reflect it over the X-axis, the x-coordinate is still going to be positive 4, but the y-coordinate is going to change and become its opposite. So it's going to become positive 2, which is why A prime is located where I just put it. B, when I make it become B prime, reflecting over the x-axis, instead of going up 2, it's now going to be going down 2. So that is where B prime will be located, making it 0, -2. And then for C to C prime, it's reflecting over the x-axis, which will now put it down here. And then we have to draw that triangle, because that's what the directions said to do. We're graphing the triangle and its image. So here you go. Here's the image. I have it in red for you. Those of you who are using regular pencils at home, yes, I know this is going to start looking a little hard to, decipher which one's the original, which one's the image. So it definitely helps to have it in different colors here. But there you go. And we have followed the directions. Now, actually, the directions did not say that you had to name the ordered pairs of the image. So I only put that over here on the left for those of you who find it easier to figure out the ordered pairs first, then graph it. Again, that's a matter of personal preference. You decide which way you want to do it. All right, problem number 3. Definitely do this one on your own. So hit pause on the video, do number 3 on your own, then hit play when you're ready for me to go over it. All right, I hope you've done this problem on your own. You've already hit pause, now you've hit play. Let's see how you did. We have a parallelogram. We have to graph the parallelogram and the image after a reflection over the y-axis. Did you notice this is not the same axis that we were reflecting it over on problem number 2. Number 2 was over the x-axis. Number 3 is over the y-axis. So you need to make sure that you had it reflecting over the y-axis. All right. So the original parallelogram used to be over here on the left, except for the ordered pair of 1, 4, which is point L. That's over here in quadrant 1. If I reflect it over the y-axis, then this is how the new parallelogram is going to look. Now, M and M prime end up being the exact same point, because if you reflect a point about the y-axis, but the point's already on the y-axis, well, then that point's not going to move. So point M and M prime are the exact same dot. L, instead of going to the right, is now going to the left. K now will go to the right for K prime, and J, instead of going left, we're now going right for J prime, and then you can see how that parallelogram looks. Again, it's a mirror image of what it used to be. That's how reflections work. All right, problem number 4. Sandra wants to rearrange her bedroom, so she drew the floor plan of her bedroom on a coordinate plane. If her bed was originally located in the second quadrant, which quadrant will it be in if she reflects its position over the x-axis? All right, do this problem on your own. If you do not remember your quadrants, maybe you need to hit pause, pull up the video I did on translations, because in the first few minutes of that video, I did review what the quadrants were. So if you forgot which one's Roman numeral 1, Roman numeral 2, Roman numeral 3, and Roman numeral 4, then maybe quickly check out that video so you can get a quick refresher on your quadrants. But go ahead, hit pause, do number 4 on your own, and then hit play when you're ready for me to go over it. All right, I hope you've done this problem on your own. Let's see how you did. So, quadrant 2 would be the top left quadrant. If you remember, quadrant 1 is the top right quadrant. And then the Roman numerals for the quadrants go in counterclockwise order. So if Sandra or Sandra, however you pronounce her name, if she is putting her bed originally located in the second quadrant, I have it here in blue, and she's going to reflect it over the x-axis. You guys do recall which one is the x-axis? It's that one right there. I highlighted for you. Then where is the new bedroom, or sorry, not bedroom, the bed going to be? Well, instead of being up here, it's reflected over the x-axis, so it would be down here. What quadrant is that? That is quadrant 3. Now, do you have to draw a sketch like I just did? No. But for those of you who cannot visualize this, or you struggle to visualize problems like this in your head, then guys, do a quick sketch of an x and y axis, draw the bed in quadrant 2, highlight the x-axis like I just did, and then figure out where's it going to be once I reflect it over that x-axis. So this only takes like 5 seconds of drawing or less to do. This is not going to take you much more time. I'm not trying to give you a lot of extra work here. If the sketch helps you to do it right, then draw the sketch. Do what you need to do to get it right. All right, moving on. Problem number 5. If you think that you can do number 5 on your own, please go ahead and try it on your own. However, if you don't think you're going to be able to do it on your own, I have no problem with you listening to me as I lead you through it. Because there's later going to be some independent practice that I want you to do number 6, 7, 8, and 9 on these guided notes. So if you want to do number 5 with me, that is fine. Here we go. It says triangle CDE has vertices, and then you can read what they are. When reflected, D prime has coordinates 4, -5. Find the coordinates of C prime and E prime. Then describe the reflection from triangle CDE to triangle C prime, D prime, E prime. All right. Again, if you need a visual cue to help you, then quickly sketch an X and Y axis so you can look to see what's happening here. We had D, and then they tell us what D prime is. So where would D be? -4, -5. That would be left and then down. So that's somewhere around here. Just kind of sketching this real quick. Now, when reflected, D prime is going to +4, -5. So you would go to the right 4 spaces, but still go down 5. I hope you can now see what I can clearly see. This is a reflection over the y-axis. So I can already answer the very last part of this problem where it says to describe the reflection. I already know what that is. This is a reflection over the y-axis. All right? But I still have to do the other part of the directions that said find the coordinates of C prime and E prime. So I still need to do that. Even though I was able to do the last sentence part of the directions, I still got to figure out the coordinates for C prime and E prime. So remember how D and D prime, the relationship that we saw here, it was -4, -5, but now it's +4, -5. So the X coordinate is going from a negative to a positive. It is becoming its opposites, like multiplying by -1, like I said on the very first page of the guided notes. But the Y coordinate is staying the same. So I need to do the exact same thing with C to C prime and then E to E prime. Like we had with D to D prime, the X coordinates became their opposites, but the Y coordinates stayed the same. So same thing happens here for C prime. The X coordinate becomes its opposite, and for E prime, the X coordinate becomes its opposite, but the Y coordinates will stay the same. That's what's going to happen. Again, I know some of you could have done this without the little sketch for the visual assistance, but I know others of you are definitely visual learners. If you can see it, then you can understand it better. So if you need to do a 4-second sketch or a 5-second sketch or whatever it takes, then do it so that you can get these problems right. Okay, for 6, 7, 8, and 9, they all have the same directions, and I have it for you right here at the top of this slide. I'll read it out loud. You're going to end up doing these problems on your own. It says, for the following problems, identify each transformation as a translation or a reflection. So, ladies and gentlemen, it could be one or the other. It might be a translation or it might be a reflection. So you might want to pull out your translation guided notes and quickly look over them to kind of get a refresher on how translations works. Because 6, 7, 8, 9, it could be either or. You got to figure out which one it is. So that's the first part of the directions. Identify which one it is, whether it's a translation or reflection. Then describe the transformation. So if it's a translation, tell me how many units did it go left or right? How many units did it go up or down? If it's a reflection, the way you describe a reflection is by telling me what was it reflected over. Like on problem number 5, we said it was reflected over the y-axis because we could see that. So that's what I mean by describing the transformation. I'll say it again. If it's a translation, then tell me how many units it moved, like left or right or up or down. Sometimes it moves both ways. If it's a reflection, tell me which axis it was reflected over. That's how you describe the transformation. So hit pause on the video, do 6, 7, and also 8 and 9 on your own, then hit play when you're ready for me to go over this. All right, I hope you've done these problems on your own. Let's see how you did. Problem number 6. We have the original football over here on the bottom right. It now has moved to the bottom left. Has the orientation been flipped? No. So this is not a reflection over the y-axis, because if it would be, then the football's orientation would have been flipped. This football looks exactly the same on the right as it does on the left. Therefore, if you thought this was a reflection, fix it, erase it, and change it now. This is a translation. Now, how many spaces did it move to the left? The corner used to be here. It has moved 1, 2, 3, 4, 5, 6, 7, 8 spaces to the left. And so that's how I would describe this. It is a translation, 8 units to the left. Now, problem number 7. Is the orientation the same? If it is the same, then this is a translation. But if it's not, then we have to consider this being a reflection. Let's take a look at this. The diagonal bar used to go like this, but now it's going like this. That has obviously been flipped. So this is not a translation. This is a reflection. It must have been flipped over this axis, which you better know what this is. That is the x-axis. So that's how you would describe problem number 7. It is a reflection over the x-axis. So if you had 6 and 7 wrong, here's what you need to learn. If the figure is the same orientation like we have with the footballs, then it's a translation. It's just being slid, sorry, past tense. But if it is not the same orientation like we had here with the circle with the diagonal slash in between, then it's been flipped over an axis, and that would be a reflection. Now, problems 8 and 9, there are no drawings. Now, are you allowed to do a sketch? Of course you are, if that helps you. But up to you if you need to. Let's see how you did on 8 and 9. Again, I hope you already did these problems on your own. Let's see how you did. Problem number 8, triangle ABC. We can see what the vertices are. Now we see what the vertices are for the image. Now, we got to be observant. Let's take a look at the first ordered pair. It was 10, positive 3, but now it's 10, negative 3. So the x stayed the same, but the y changed and became its opposites. That sounds like a reflection, like we learned on the very first page of these guided notes. But be careful. Is that happening on all the others? What about b to b prime? Let's take a look. The x's stayed the same. The y's, yes, they did. They changed and became their opposites. Did that also happen with c? Let's see to c prime. We had the x's were both negative 2s. The y's, I see, went from negative to positive. So I now have the proof that I need that this is a reflection. Now, which axis has it been reflected over? You can either go back to the first page of your guided notes and notice which one is it when the y coordinates will end up becoming opposites, but the x's stays the same. Or better yet, you could have done a quick sketch of A and A prime and looked for yourself to see which axis this was reflected over. It was reflected over the x-axis. All right, problem number 9. Trapezoid RSTU, we can see what its vertices are. Then we have the vertices of the image. Now, again, we need to be observant. What has happened? From R to R prime, it looks like the X became the opposite, but so did the Y. Well, that's odd. Does that happen with the others? From S to S prime? No, not at all. From T to T prime? Nope. So if you thought there was a pattern that the X's changed and the Y's, I got news for you. That is not a pattern that continues with S to S prime, T to T prime, and U to U prime. So this is not a reflection. It can't be. This has to instead be a translation. So I need to figure out what could I add by to get from -4 to +4? What could I add by to get from 6 to -6? Now, you might be able to figure out that mentally and then check to see if the math works with the other x coordinates and y coordinates for S, T, U to S prime, T prime, and U prime. Or you can do like I kind of showed you on your translation guided notes, set up an equation. I know that -4 plus something, call it x, would equal +4. How do I solve? Well, I can subtract by -4, which is the same as adding by +4, and that will tell me that x gets by itself. 4 plus 4 gives me 8. Then I could check, will that 8 also work? If I take -5 plus 8, would I get +3? Yes, I would. If I take 1 plus 8, do I get +9? Yes, I do. If I take 0 plus 8, do I get 8? Of course I do. So there I go. I know that the x's are being added by 8. What about the y's? I know that the +6 for the r becomes -6 for the r prime's y value. So 6 plus something gives me -6. I can subtract by 6 on both sides. Subtraction is the same as adding the opposite. Perhaps you actually did that here with your pencil. Add the opposite, and that's going to give me that y is going to equal -12. Now, I can check, would that work for the other y coordinates? Let me change highlighter colors here for you. If I take -2 plus this -12, will I also get -14? Yes, I would. Same thing happens here with the t and t prime. If I take the u of 6 and add it by the -12, do I get -6? Well, yeah, I would. So there you go. I have my proof that I can add by an x of 8 and a y of -12 to continue to get the coordinates of the primes, r primes, s prime, t prime, and u prime. Now, the directions said, don't forget the directions, describe the transformation. So, write me a sentence real quick. This is a translation. Since the x is +8, that is 8 units to the right, because an x that's positive goes to the right. And the y would be -12, so that means 12 units down. And there you go. That is the description for the translation for this problem. All right, guys. Thanks for doing the guided notes here on reflections. We will see you next time.